Greetings, detectives. Mrs. McKay here, and we're going to learn a little bit about rotations, explore them a little bit more, and find out some cool things related to them and how they relate to slopes of lines. So let's start by writing our learning target, clue 6.3. I can use the slope of perpendicular lines to rotate an image 90 degrees. All right, I can use the slope of perpendicular lines to rotate an image 90 degrees. Please make sure that you have written that down. Let's take care of a few pieces of information. First of all, a rotation equals a turn, okay? It's taking an object or an image and turning it around a point and moving it in a circular motion, all right? So it's a turn. We take this object out here and we rotate it, we move it around a circle, all right? Here's our center point. So that's important to know and understand. There are going to be three things that you will always need to know, three pieces of information or three instructions that you'll always need to know to perform a rotation. You're going to need to know the angle measure. So that's going to be anywhere between 1 degree and 360 degrees. So it'll always be written, you know, like here's 90 degrees or 180 degrees. Those are the two that we'll spend the most time today talking about. You're going to need to know the direction, and that will either be counterclockwise, which means the opposite of the way that a clock moves. So counterclockwise goes this way. Okay, that's counterclockwise. Or it will be clockwise, and that is the way that a clock goes, which is this way, the direction a clock goes. Counterclockwise is considered a positive direction. Clockwise is considered a negative direction. So sometimes you might see instructions that say go a negative 35 degrees or a negative 90 degrees. Then you know you're going to go clockwise. Okay? But if you see that it just says rotate it 45 degrees, then you know you're going to go a positive direction, and that's going to be counterclockwise. So that's just an important thing to know, your direction. And the last thing that you're going to need to know when completing rotations is the center of rotation, and that's usually a point on the coordinate plane. So it will say rotate about or around. Sometimes it'll say around or about, then a point, X, Y. All right, so those are important things to know, and you're going to need to always look for those three pieces of information. All right, okay? Now, before we do anything more, I want you to take a look at this website. This website is called mathopenref.com, and then you can actually search under the table of contents for transformations, and then rotation of a polygon. But I just want you to play around with it a little bit, and I want you to see what you can do. Basically, it's got a figure. It's got this blue figure, and then it has a point, this C point, and that's our center of rotation. And I can move that point anywhere I want. So I can put it here, okay? And what this is this blue one is my pre-image, and the yellow, the white colored yellow one, is my image. And right now, this is rotated from this image. The blue, the pre-image, is being rotated along this center point, and it's being rotated 57 degrees. Okay, now so you can see that it's going in the counterclockwise direction. Let me see if I can make this a full screen so you can take a look at it. So here you can see it says drag the center of rotation. I can move my center of, I can make it close, I can make it far away, I can do all kinds of things. And then, do you see this little tiny pink dot here? I can actually drag my figure, and as I drag it, I'm basically rotating this figure around this center point, and I'm changing my angle of rotation. I'm changing my angle of rotation. So right now, from here to here, from this figure to this figure, it's 143 degrees. If I keep rotating it, if I can get it to be, now it's going to 100-88. Let's see if I can. So I just want you to kind of, so that's the first thing I want you to really do is go ahead and pause the video, go to this website, and see if you can just play around a little bit with so this is at 0 degrees, okay? And it's currently around this center of rotation. So I'm going to move it right about there. This is 0 degrees. So I want you to play around with it a little bit. So I'll just do it a few more times so that you can see what I'm doing. Then I can drag this, and you can see as I drag it around this circle, I'm getting to different angles. Notice when I get to 90 degrees that it's making a 90-degree angle here. See that? And then I can continue to drag it. Having a little bit of trouble. Let's see if I can do it this way. Yeah, that's better. Not sure why it suddenly becomes, that's 180 degrees. Not sure why it changes it to a negative 180. I guess then as I go around, back to 0. If I go this way, if I go in the clockwise direction, it is the negative, and then when I get to here, it should become positive 180, but I don't know why it doesn't, but that's all right. And again, then you can see that I can just keep moving it around. So it's important for you to get the feel of what's happening when we rotate. Let me put it back at 0. Let me move my center of rotation out a little bit and grab this, and you can see how it looks now at 90. So you can see that as it's farther away at 180, as it's farther away from, as my image is farther, my pre-image is farther away from the center, then so is my final image. As I move my center in, I could do this. So there's lots of fun things to play with, and I want you to spend some time doing that, all right? So make sure that you go to this website and just play around with the whole idea of rotating images. So go ahead and pause it, play around at this website, and then when you're ready, come back, okay? All right. Okay, so hopefully you had a chance to play around a little bit. Now, what we're going to do is we are going to just look at some rotations and identify the points. So this purple, light purple rectangle is rectangle ABCD. A, B, C, and D, okay? And I'm going to go ahead and also just identify the points with different colors. So these are called the vertices. So that's A. A will be bright green, B will be bright yellow. We'll make C be orange, and D can be this sort of pinky color. Okay? Now, what we've been told in our directions is to rotate A, B, C, D 90 degrees clockwise. So that means this way. Okay, so we're going to take this entire thing, we're going to rotate it clockwise, and we're going to do it around point D, which means that point D stays where it is, and the rest, it's like we took our finger or our pencil and we held it down, held the purple, light purple rectangle down at point D, but moved the rest of it like it was a playing card or something, and moved it around the circle, moved it down. So then that means that now what I want us to do is I want us to identify where point A ended up. Well, point A would have ended up right here, right there. That's A. Okay? And then point B would have ended up right here. So here's point B. And actually I want to make sure that I label A as A prime and B as B prime. And then C, which was our orange one, rotated around all the way to here. So this would be C prime, and then D stayed the same. See what I just did? So I just moved D from here to here. Basically, this line came down here, D stayed in the same, and then A came down to here, down to this point, B came down to this point, and C came down to this point. Do you see how that rotated 90 degrees? Okay, so now let's take a look at this next one, and let's see if we can identify where our points went to. So we've got this triangle EFG, triangle EFG, and let's go ahead and make our points. Well, I guess I should make them different colors again. So we'll have a red one, F can be blue, and we'll make E green. Okay, so this time our directions say we're going to rotate EFG, but this time we're going to rotate it 90 degrees counterclockwise, which means we're going to go this direction. Okay, so we're going to rotate it around the origin. We're going to rotate it around the origin. So what I want you to do is imagine that we have this on a transparency and that we're holding down the EFG and we are rotating, we're holding it down at the origin and we're rotating the transparency around until it fits into this origin. Another way that you could think about it is you could actually pick up your paper and turn it 90 degrees, and then you would see that this triangle ends up over on this side. Okay, so let's think about where each of these points ends up. So we've got G rotates around to this point right here. We'll call this one G prime. And then we have E rotates all the way around to the tip over here. We'll call this one E prime. That's an E. And then F, which was our blue one, rotates around to here, and that's F prime. Okay? So we've just taken this entire kind of light brown triangle and rotated it around the origin. So that means that this triangle moved and kind of rotated around until it was sort of laying flat on its back. It made 90 degrees. Now, that's sometimes difficult to actually picture and see, and so that's why I gave you transparencies in class today. Now, I want to show you a new way that we can actually think about rotating things without having to move papers, and we can always do that. We can take a transparency or tracing paper, and we can actually shift things, rotate it around by holding it down at the specific point. But I want us to do a little exploration and think about this and see if we can find some other ways that we can visualize this and actually do this work. So take a look at my list down here, or not my list, my section that says exploring rotations and perpendicular lines. So the first thing we're going to do is we're going to follow some directions. It says consider the point A right here. So here's point A, which is at 2, 3. So 1, 2, 1, 2, 3. So this is 2, 3. All right. And consider point B, which is at 4, 7. 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. So there's point B. Okay. So we've got point A, which is at 2, 3, and point B, which is at 4, 7. And this line segment that is connecting them. The question is, what is the slope of this line segment? Take a look at it and write down or tell me what is the slope of this line segment. Well, to get from this point to this point, we had to go up 1, 2, 3, 4, and over 2. So the slope is 4 over 2 or 2 over 1, right? 4 over 2 or 2 over 1. Everyone see that? Okay, so now the next thing it tells us to do is it tells us to locate a third point that we're going to call C at some place x, y on this grid so that when we connect points A, B, and C, we're going to form a right triangle, and AB is going to be our hypotenuse. Okay, so I think that I'm going to go ahead and just put a point right here and call this one C. Okay, because now when I connect A to C, whoops, and B to C, then I get a right triangle. Everyone see that? Now, how do we know? How do we know that this is a right triangle? Tell me how you know that this is a right triangle. Give me an explanation. Well, one of the things that you should have noticed is that we made it a right triangle because our grid where these lines cross actually make the right triangle right there. We went right along this same line of y equals 3, and then we created another one right here along x equals 1, 2, 3, 4, and where these two cross, we made a right triangle. So we know, or a right angle. So we know that this is a right triangle. Okay? Now, suppose we were going to rotate. We were going to rotate this triangle around the vertex point of 2, 3, right around this point right here, 2, 3. Okay, we're going to take this triangle and we're going to rotate it. Let's go ahead. Well, we can rotate it any way we want, but we'll go ahead and rotate it counterclockwise around this so that this line is going to move in a direction. It's going to move upwards. It's going to rotate this direction, and it's going to go all the way up until it hits this line, because that's going to make this right here a right angle. Do you see what I'm saying? I'm going to take this line right here, this line AC, and I'm going to rotate it up till it hits this line up here to make a right angle. So that way I know that I'm rotating this triangle 90 degrees. So let me go ahead and use a different color. Maybe I'll use green, and I will create my new triangle. So I'm going to take this line right here, this AC, and I'm going to rotate it, goes 1, 2 over. I'm going to rotate it up so it hits right here, and it's going to make a line like that. Okay? And then that means that I will then, this is the bottom of my triangle. So now my triangle is kind of, the hypotenuse is coming down this way, and this side is coming this way. This C is going to come around, and it goes 1, 2, 3, 4 in that direction. So I'm going to go 1, 2, 3, 4 in that direction. And now you can see I can just connect right there. So I've just taken my triangle and I've rotated it 90 degrees around this point A. So A stayed the same, but B moved to over here. So this is B prime, and C is right here, which is C prime. Okay, so do you see what I did? Do you see how I rotated that around that point A? So we've just rotated our triangle, and now what I want to know is, what is the slope of our new hypotenuse? Because notice that we now have, this is our right angle, and our hypotenuse is still AB, but it's now AB prime. Okay, so here's our hypotenuse. What is the slope of our new, the slope of this new hypotenuse, AB prime? So what is the slope of it? Well, let's see, from here to here, figure out what the slope is to go from A to B. So you should have said, well, I went up 2 and over 4, so back 4, so up 2 and back 4. So my slope is 2 over negative 4, or a negative 2 over 1. Do you see what I did? It's a negative 2 over 1. So the slope, now I want us to think about the slope of my original pre-image, which is A, B, C had the slope of 2, right? And my slope of my new image, my rotated right triangle, which was A, B prime, C prime, the slope of its hypotenuse was -2. No, it wasn't. No, it wasn't. It wasn't -2. It was -1/2, right? Because -2 over -4 is a -1/2. Oh my goodness. Almost messed up completely on that one. -1/2. So the slope of my pre-image was 2, and the slope of my rotated image was -1/2. Do you see that? So I want us to do this again on this line CD. I want us to follow these same steps on CD and see if we can see a pattern, because I want you to look for a pattern. So we're going to start again and we're going to say consider our points, but now instead of it being A, B, C, it's C and D, and we'll create a new point that we will call E. And we're going to go ahead and make a another point so that we can, well, actually before we do that, let's figure out what the slope of this line segment is. So let's look at D. So from D to C, or you could do from C to D, either way, from D to C, but I'll do D to C because I like to read from left to right. From D to C, what is my slope? Well, you should have said to get from D to C, I went up 1 and over 3. Up 1 over 3. So my slope is 1/3, okay? Now the next thing I need to do is create a third point, and we have to make a right triangle. So I have two different, and my hypotenuse has to be CD. So I see lots of places that I can make my right triangle. I can make my right triangle. Well, not lots. I see 2 places. I can make it here. I can put a point there, and I can make my right triangle going this way. Or I could make my point there and make my right triangle going this way. Do you see what I just did? So I could go. So I think what I'll do is I'm going to go ahead and make my point right here, and that's going to be E. Okay? And then I'm going to make my right triangle. So I'm going to connect C to E, and then I'm going to connect D to E. And now I have a new right triangle. There it is, right there. Okay? Now, the next thing I need to do is I'm going to go ahead and use this new point, E. Actually, no, I'm not. I'm going to use C. I think I could use E as well, but I'm going to use C. And I'm going to rotate it around this vertex point. So I want to still use one of my original points, okay? So I'm going to take my C and I'm going to rotate it, and I can take this line right here, this EC line or CE line, and I'm going to rotate it, and I think I will rotate it 90 degrees. I'm going to rotate it 90 degrees, and I think this time I'm going to continue to rotate it in the counterclockwise just so that I'm not overlapping on my others here. So I'm going to take this line, okay, and I'm going to rotate it 90 degrees this way so that my EC ends up being here. Okay, so I'm taking my entire, I'm going to take this whole thing and move it down this way, because this is the point that I'm rotating around. Let me see if I can make it be obvious. This is my rotated point. That's the point that's staying set, okay? So when I rotate it, let's pick another color. Let's make it be maybe like this pinky purple. When I rotate it, the C stays the same, but the E goes over here. So notice how I've just made a right angle from here to here. So here's my C. This becomes my E prime. And as this moves down, let's see, this was 1, 2, 3. This is going to come down 1, 2, 3. So this is going to be my D right here. This will be my D prime. This was my E prime. Okay, and now I have this line, or this line segment that I can create connecting E to D and then C to D here. Okay, so I've just taken this triangle and I've rotated it, zoop. I've just moved it this way, so I've taken it 90 degrees. I've moved it along using C as my anchor point, okay? That's my rotation. It's where I'm rotating around. So now, we've already said that the slope of the hypotenuse of C to D was 1/3. Now let's look at the slope of C to D prime. What is the slope of C to D prime? Take a minute, figure it out for me, please. Okay, so C to D prime. How did I get from C to D prime? Or I could say, how did I get from D prime to C? But let's go ahead and do C to D prime. So I went down 1, 2, 3. So I went down 3, so that would be -3 over, and then I went so I went 1, 2, 3, down 3, +1. Okay, so let's take a look at these two sets of slopes. I've got my first triangle that when I rotated this blue one 90 degrees, I had a slope of my pre-image was 2/1. And the slope of my rotated image, when I rotated it 90 degrees, it was -1/2, or -1/2. First slope was 2/1. Second slope, -1/2. First slope on my CDE was 1/3. So my hypotenuse was 1/3, up 1/3, okay, +1/3. And my rotated slope was -3/1. -3/1. Do you see any kind of pattern? If you do, tell me what that pattern is now. The thing that I want us to notice is I want us to notice that the slopes are the opposite reciprocals, or negative reciprocals of each other. I want you to take a look at the slope, again I said, of these hypotenuses, right? So here's a hypotenuse, and then here's a hypotenuse. And I want you to look at this and realize that this is actually also a right angle. Do you see that? That these two lines are actually perpendicular to each other. The hypotenuses are perpendicular to each other. Look at it here as well. Here's a hypotenuse and here's a hypotenuse, and they are actually perpendicular to each other. They make a right triangle. So these hypotenuses, these two lines, AB and AB prime, are perpendicular lines, and their slopes were 2 over 1, and then the new slope was -1 over 2. And the other slope was 1 over 3, and it changed to -3 over 1. Perpendicular lines have a very interesting relationship. Do you remember parallel lines having the exact same slope? Remember how parallel lines have equal slopes? Okay, these are parallel lines. Well, perpendicular lines, lines that form a right angle, have negative reciprocal slopes. Negative reciprocal slopes. Negative reciprocals. Look at this. 2 over 1. If we take the negative reciprocal, that would mean, the reciprocal would mean we flip it over and it would become 1/2, and we take the negative of it. If we have -1/2 and we want to say what is the line that is perpendicular to it, we would flip it over so that it becomes 2 over 1 and take the negative or the opposite of it. So the opposite of negative is a positive. So the opposite of -1/2 is a positive 1/2, but we want the reciprocal of it, so it becomes 2. Same thing here, 1 over 3. Take the reciprocal, so you flip it over and it becomes 3 over 1, but we need it to be the negative reciprocal. This is true of all perpendicular lines. Their slopes are always the negative reciprocal. So basically the opposite, right? The opposite in terms of positive and negative, and then the opposite in terms of numerator and denominator. So flip them and find the reciprocal. So that's a very cool thing to know about lines and slopes of lines. And the reason it is so cool is because when you have 90-degree rotations, when you have a 90-degree rotation, wherever your center point is, if you draw a line from your center point, and in this situation, these center points were actually one of the points of the image, but if you draw a line from your center to your other points, and you form a 90-degree angle, your slopes of those lines that you created will be negative reciprocals. So let's take a look at it on this one up here, where we have our center point not being the actual one of the points. Let's look at this one here, where we had this, our center point was the origin. So here's our center point. And my question is, if I'm going to draw a line, because remember, I'm kind of creating a radius of a circle. If I drew a line from G, or from my center point, my center, to my first point G, and I wanted to rotate it 90 degrees to G prime, So you can see that I've just made a 90 degree from here to here was 90 degrees, right? Well, let's find out what the slope of these two lines are, these little line segments. What's the slope from the center to G? What's the slope? Well, it's 1 over 1, right? Positive 1 over 1, up 1 over 1. What's the slope from the center line to G prime? Well, it's up 1, back 1. So it's 1 over negative 1. Well, if these are perpendicular lines, then that means that one of the slopes, negative 1 over 1, is the negative reciprocal of the other slope, which happens to be 1 over 1. So if we flipped 1 over 1, it would be 1 over 1, but we have to take the negative of it. So is negative 1 over 1 the negative reciprocal of 1 over 1? Yes, it is. Let's take a look at a different one. I need a different color here so that we don't get too confused. Let's look at from our center to E. So I'm going to go ahead and make this be a line that we can... We've got from our center to E, right there, and then we have from our center to E prime, right there. So the question is, what's the slope of the line segment from the center to E? Tell me what the slope is. It's 1, 2, 3, 4 over 1, right? And what is the slope from the center to E prime? Well, it's negative 1 over 4. Do you see that? 4 over 1, and then the slope of this one is negative 1 over 4. So 4 over 1, negative 1 over 4, negative reciprocals. Flip it, take the negative. Let's see if that ends up being the same thing for our F's. So we have to connect from our center point, our center of rotation. We connect the center rotation to F, and let's connect it also to, having trouble with my tablet, F prime, and let's figure out what the slopes are. You go ahead and tell me what the slope is from center, from C to F. What's the slope? 1 over 3, correct. And what's the slope from center to F prime? Negative 1 over 3. Oops, sorry, not negative 1 over 3. Negative 3 over 1, right? Because we went up 3 but back 1 in the negative direction. So notice again, we've got 1/3, we've got negative 3 over 1. Therefore, we're looking at the negative reciprocal. So that's just a really, really cool thing. I love that. I love that that happens that way. So now what I want you to do is I want you to go ahead and take a look at some, well, actually, before we do that, let's go ahead and write some notes here about 90-degree rotations, because I want you to realize that 90-degree rotations make perpendicular lines, okay? from the center. Okay? So you can always rotate something 90 degrees, and you don't have to try to shift your paper. You just have to think about your slopes of your lines. Figure out the slope of one, from the center to one point. What's that slope? Take the negative reciprocal, and from that center point, do the negative reciprocal slope and find the other point. And you can do that with each of your points and then connect them, and you've rotated it. Now there's another thing that you can do that is another shortcut, and I want you to notice this. Let's go ahead and do point F. Point F, what is its coordinate point? It's 1, 3, 1, right? It's 3, 1, okay? The point of F is 3, 1. What is the coordinate point of F prime? It's negative 1, 3. Do you see a pattern? 3, 1, negative 1, 3. Take a look at E and E prime. What's the points, or what is the coordinate point of E? Well, the coordinate point of E is 1, 1, 2, 3, 4. So 1, 4. And what is the coordinate point of E prime? It is negative 4, 1. See anything here? Notice anything? The last one is C. Let's do C. The point of C, I'll do it in red. C, not C our center, but C our point over here, was 1, 1. And the point of C prime is negative 1, 1. Now that's not as helpful because we've got both of this as a 1, 1, but these other ones are very interesting. So here's another thing that might help you when doing 90-degree rotations. You've got your first point, XY. It translates to whatever Y was, your X now becomes the negative version of that Y, and your Y becomes still the positive version of that X. It's like these two flipped places. They changed places and the Y became a negative version of it. So if that doesn't make sense to you, you can do a few more, but that's just a little shortcut that helps you to think about plotting those points. All right. Now let's do some practice. First off, what are the coordinates of the vertices of this rectangle, MATH, math? What are the coordinates of the vertices of that rectangle? Please record the vertices, each of the corners, each of the points. Do that. So you should have said that M was 1, 2, 3, 4, 5, 6, and A was 1, 2, 3, 6. T was 1, 2, 3, 1, and H was 1, 1. All right? Now, rotate the rectangle 90 degrees counterclockwise around the origin and label each point M prime, A prime, T prime, H prime. So go ahead and see if you can do that. You'll probably need to pause it and see if you can do that. And if you're having trouble, then we'll do it one step at a time. But try it first on your own. Try to do this point right here. this H point. Okay, try and do that one. So what are the coordinates of each vertex? Well, H prime would have been right here, right? Because we would have taken the slope here and done the negative reciprocal. So the slope of this one is 1, the reciprocal is -1. So the vertex of, or the vertex of H prime is -1, 1. Okay? Now, see if you can do point M. Where would M rotate to? Well, M, think about what the slope is from your center point all the way up to M. You went up 1, 2, 3, 4, 5, 6, and over 1. So now that's my slope, 6 over 1. So my slope for M prime is going to be negative. This was 6 over 1, so my slope for M prime is going to be negative 1 over 6. So that means that I'm going to go up 1 and over 6 this way. 1, 2, 3, 4, 5, 6. One, 2, 3, 4, 5, 6, and this is my M right here, M prime. Okay, so my M came zoop down here. Now, once I do a few, I've got my H and I've got my M, I could do each of these. I could do the same thing. I could look at my slope, take the negative reciprocal. But once I've gotten a few, I can actually just draw it out, can't I? Because I know this rectangle, if this is my long side, MH, M prime, H prime, then this is going to be my T, and this is going to be my A. And now I have my vertices, don't I? So the vertices of my coordinates are, for H, let's see, -1, 1, and -6, 1, and this one is -6, 3, and -1, 3. So you can see again, this is T prime, this is A prime, that how these have this pattern, and I can actually connect those, okay? So now we're going to do one more thing. After I draw my little, we're going to rotate our rectangle. Did a terrible job of that. We're going to rotate our rectangle another 90 degrees and label each of those points. So now we're going to take these points and rotate them another 90 degrees in the same direction, counterclockwise. So see if you can do that now that we've done it once. See if you can do it on your own. Pause it, try and do it on your own, and then figure out what your vertexes are. So hopefully you did the same thing. You thought about your H moving to right here. And then let's see, your M is going to need to come down this way. 1, 2, 3, 4, 5, 6. Your A is going to go right here. And your T is going to go right here. So this was M prime 2, A prime double prime, T double prime, and H double prime. Okay, and we can connect our lines and our vertices. Are, let's see, this is -1, -1. This one is -3, -1. This one is -3, -6. And this one is -1, -6. So when we rotated this a full 90 degrees and another 90 degrees, we actually rotated it 180 degrees. If you think about it from here to here, this was 180 degrees. And what do you notice about these vertexes? Well, 1, 1 became -1, -1. 1, 6 became -1, -6. 3, 6 became -3, -6. And 3, 1 became -3, -1. So when you rotate something 180 degrees, xy becomes -x, -y. Pretty cool. All right, this has been a long video, but there's some really cool things about this. And if you're really struggling with this, you'll need to probably spend a little bit more time on that website, this one, where you can play around, with this, okay? So with playing around with just rotating things. All right, it's time to write a key idea. Go ahead and write your key idea, and I'll see you in class. Thanks for your patience.